So when we're dividing polynomials, the reason that we're doing this is because when we have a degree higher than 2, and we don't have a common factor that we can pull out of an equation, we are going to run into some trouble. So this is going to allow us to break down and factor higher order polynomials and eventually be able to find the roots. Before we can do any of that, we just have to review how to divide numbers using long division and some of the terminology with that. So let's say we had 188 divided by 5. Those are kind of small, friendly numbers to work with. But we know it's not going to divide in evenly. There's going to be a remainder. So let's go through and just review some of the terminology. So the number that you are dividing is called the dividend. So that's the number here that goes under my division symbol. The number that I'm dividing by, the 5, is called the divisor. And the answer that I'm looking for here is called the quotient. So that's just a review of some of the terminology. So what we do when we are doing long division is we start by looking at how many times does 5 go into 18. So how many times does that divisor go into 18? So 5 goes into 18 3 times, because 5 times 3 would be 15. And that's going to leave us with 3 left over. So subtracting is the next step. And then we bring down the next number. So we bring down the 8, the next number in the dividend. And then the whole process starts again. So how many times does 5, the divisor, go into 38? Well, 5 times 7 is 35. And then again, we subtract and we end up with 3 left over, and that's all we can do. So the remainder here is 3. So if I was to write a little bit of a division statement for this question, I could say that 188 can be broken down as 5 times 37 plus the remainder, which is 3. So again, the 5, the divisor, goes into the dividend 188 37 times. So 37 is my quotient. And the remainder is 3. So that same process we're going to need to do with some algebraic expressions. So if we had something like x cubed minus 5x squared plus x plus 6, and we wanted to divide it by x plus 1, in this case, my divisor is x plus 1, my dividend is the expression x cubed minus 5x squared plus x plus 6, and my quotient is going to be the answer that I get when I do that division. Anything left over after that process will be the remainder. The only difference here is that we're using polynomials instead of numbers. Okay, so let's take a look at doing long division then with a polynomial. So we're dividing x plus 1 into x cubed minus 5x squared minus x plus 6. So the first thing I want to do is just, because we're dealing with a binomial here, we're just looking at the first term in the divisor, and we're asking ourselves how many times does that go into the first term in the dividend. So x goes into x cubed x squared times. And I'm going to write that in the x squared spot. I'm calling this the x squared spot because it's where the x squared term is in the dividend and in the quotient. So if I then multiply x squared by x plus 1, I would end up with x cubed plus x squared times 1 would be x squared. So how many times does x go into x cubed? It goes in x squared times. And then I multiply the x squared by x plus 1. And that's what I wrote here. The next step, just like with numbers, is to subtract. So it's important that everything is lined up here by power. If you have any terms that are missing, so for example, if you had 0x's included there, you would want to write in the 0x as a placeholder. So we want to subtract. We have x cubed minus x cubed is 0x cubed. Negative 5x squared minus x squared gives me negative 6x squared. I'm going to bring down the minus 1x, and then the whole process starts again. So how many times does x go into negative 6x squared? Well, it goes in negative 6x times, because negative 6x times x is negative 6x squared. And then I'm going to multiply that negative 6x by the expression x plus 1, and that's what I'm going to write down here. So I'm going to end up with negative 6x squared minus 6x. So I'm multiplying negative 6x by x and negative 6x by positive 1. And then I need to subtract. And if I'm doing this correctly, I should notice that the higher powered term is canceling and it's making 0. So negative 6x squared subtract negative 6x squared is 0x squared. Negative 1x subtract negative 6x, that becomes plus 6x. So we're going to end up with 5x down here. Okay. And then we are going to bring down the positive 6, and the whole process is going to start again. So how many times does the x go into the 5x that we have down here? It goes in positive 5 times. Then we're going to take that 5 and multiply it by x plus 1. That gives us 5x plus 5. We're going to subtract 5x minus 5x, 0x. 6 minus 5, 1. So we have x cubed minus 5x squared minus x plus 6 as our dividend. That equals the divisor x plus 1 times the quotient x squared minus 6x plus 5 and plus 1 as our remainder. So it does not go in evenly, and that's going to be useful when we start to talk about the factor theorem as well. Okay, so you may be able to break down this quotient further, but right now, because it's got a remainder, it won't factor any further, obviously. And also, we're just asking for dividing at this stage. So it's important to know if we're asking you to divide or to factor. We just want you to do that division there, not to actually find the factors. Okay, so we're going to just go over those steps, and then we are going to try one more example together. If you are doing synthetic division, if you find that in a textbook, that's fine. I normally just do the long division. As long as you're showing your work, you're good. So the steps again to review: divide the leading term of the divisor into the leading term of the dividend, and then multiply that first term of the quotient by the divisor and write down your answer under the dividend. You want to be careful that you're lining up terms with equal degrees. You want to subtract the last line from the line above, bring down the next term in the dividend, and repeat. So you might want to have those steps in front of you as you're working through some of the examples. Okay, so we're going to do one more together. So this is 2x squared plus 5x plus 3 divided by x plus 1. How many times does x go into 2x squared? It goes in 2x times, and I'm lining everything up in the x spot here. And then I multiply 2x times x plus 1 is 2x squared plus 2x. I need to subtract, so I end up with 0x squared plus 3x. Bring down the positive 3, and the whole process starts again. How many times does the x here go into 3x? Well, it goes in 3 times, so I'm going to put it in the constant spot up in my quotient. And then I'm going to multiply that positive 3 by the x, which gives me 3x, and the positive 3 by the positive 1, and get plus 3. When I subtract, I end up with 0. When I write my division statement, this time 2x squared plus 5x plus 3 is equal to x plus 1 times 2x plus 3 with no remainder. So we say that x plus 1 in this case is a factor because it can be broken down even further.